think we're ready, gentlemen. Hello, everybody. Hi, folks. Welcome to the SBAU Astro Hour. It's a weekly compendium on screen science blog right here on YouTube for the Santa Barbara Astronomical Unit. That is Santa Barbara, California's longtime Astro and Telescope Club. I'm your SBAU board member, retired radio guy, Ronnie Herron, your proud host. And our club is proudly based up at the beautiful and beloved Santa Barbara Museum of Natural History, where we hold our first Friday meetings. We'll have one this Friday night. A young grad student from UCSB talking about dark matter and gravitational lensing, plus second Saturday star parties. We have and use both the museum's great observatory and the little planetarium, and Sunday get-togethers with the sun in charge. Lots of other great displays of cosmology up there. This will be program number 258 for February
Whoa.
2nd. Yes, through the 8th. 257 was aborted a little early, like we made it 5-6 of the way through last week. So we may just go over another 10 minutes this week to make up for it. However, we're going to talk about a full February snow moon that happened, I guess, around 5 o'clock yesterday, gracing our night skies. Could also be called the storm moon, or they called it the snow moon, or my favorite, the hungry moon. And as for the moon starting to wane, we're going to look for a great distant galaxy in the sky, M106. Also got an update on the 16 Psyche asteroid, making a retrograde turnaround in Taurus this month. NASA's Psyche mission is going to orbit that rock. And a last look at our interstellar comet visitor, SB. No, that's not SB. That's 31. We're not putting our name on that sucker. 31 Atlas, done by the TESS spacecraft.
It's 3I Atlas.
Where is the coldest spot in the universe besides Tim Crawford's house? Well, we're going to take you up there. There's an open star cluster in constellation Camelopardalis. I think I got that right, over in the north sky. Shall we meet the gang? Our beloved leader, man in charge, commander of the starship. There he is, Jerry Wilson. Good morning, Jer.
Good morning. Live long and prosper. Good morning to my sister Joyce and my two grandkids, Calvin and Riley.
Okay, welcome aboard, all of you. He's married to the lovely Pat Forgy, the first lady of the club. Also married to a Pat is our incredible outreach captain, co-pilot, Chuck McPartland, who's married to Pat McPartland, both our club's treasurer and our merchandise manager. Does she get anybody between 6 and 6:30 and the meeting on Friday to buy anything?
Yeah, she got rid of, I think, some a hoodie and some shirts.
Well, we got smalls left, don't we? We ought to do something with the girls. We ought to do something with the kids with those.
Yeah.
Getting them into the club. Well, anyway, here is Tim Crawford, navigator for the Starship, who's married to a lady about to have her birthday, Karen, right?
Yep.
What do you do? Where do you take her on her birthday?
All the way to the front room.
Bless your heart. That's great.
We'll go out on a nice walk somewhere, I'm sure.
We lost one of our members back in mid-December, and this week missing would be Tom Whittemore, our former Westmont College professor, newsletter editor. He is, let's say, on assignment. Checking on the street demonstrations in Minneapolis or something, God knows. Selling his bread. We do funnies. We start the hour with the tunes from the president that he forwards to us, and we got a half dozen. I'm ready to comment. I looked at him. Maybe you guys did. Maybe you just wait for him to come up on screen, but always gets us in a good mood. Here we go, ladies and gentlemen. Cartoons from hell. A lot of Far Side, a lot of Gary Larson.
And I guess they're all Larsons today.
They're all Larsons. All right, the visiting aliens. What are they on a science expedition, a field trip?
They're on a guided tour. See the little sporty caps and hairdos and stuff, and
right.
The guy's saying, this is a typical Now, this is a typical dwelling of a species that, hey, all
Look at
right, I
that.
think we even caught the little fellow at home.
Nice.
That guy'll have nightmares for a while, won't he? And
There's
here
a
are the
couple,
duck hunters.
yeah, they're
Anybody want to
Yeah.
explain? You want to explain this, Chuck?
Well, it's just a couple of duck hunters hiding in the reeds, and they're looking up and have kind of worried expressions on their faces, and you can see the shadows of a bunch of pterodactyls going overhead.
You know how to spell pterodactyls, Tim?
No.
There's a PT. And oh, speaking of more aliens, Mr. Perez, what's going on here? They were at a signals
she's
bar.
recording us. Relax. In the age of AI, who's going to believe her videos?
That's right.
That's kind of good.
God, I don't believe anything I see anymore. Okay, this one. Oh, these are the colliding time machines.
Yep. Tempers flare when Professors Carlson and whatever his name is, working independent, ironically, set their time machines to the exact identical coordinates.
I couldn't see this caption because there's something in front of it. So
Yeah, that the site I get it off, they put that on there.
yeah,
And
yeah.
I can't get it off.
But there's a third element missing. You said coordinates. That's a place. You need the
Yeah.
exact same time.
No, in
Well,
a four-dimensional universe, coordinates is four-dimensional.
Yeah,
Oh, okay, got it. All right.
space
Here's the-
time.
Okay, Tim Crawford, you want to look at this one, or did you already?
Oh, I did, but I couldn't read it. Let's see.
Oh, it says, Igor, get that Wolfman doll out of his face. Boy, sometimes you really are bizarre.
Actually, wasn't it Igor pronounced in Young Frankenstein, Mel Brooks?
Yeah, it was,
It was
Yeah.
supposed to be
Oof.
Igor, wasn't it?
Yeah, exactly. It's
Or
Igor.
is it-
That was Marty Feldman.
yeah,
Yeah, that guy was hilarious. Frankenstein.
A
yeah.
lot of visiting extraterrestrials in this morning's cartoons.
Yeah.
What happened here? They're just having a picnic.
Oh, I like this one.
Innocent. What happened
pulled-
there?
He pulls a gun on him. He pulls a gun on the picnickers, and they raise their hands, and then a sign comes out with the sleeping symbols on the gun.
Well, it's a fake pistol that just goes. Zzz.
They're playing a trick on him.
Yeah.
I kind of like that.
Prankster pistol.
Okay,
Okay,
now,
it got us in a good mood to check the night sky, and here
let
we
me make
go.
a short announcement before we go on to the meat of the matter here. To give the audience some background, we work from a list I assemble of largely pictures and captions. We call it the talking points. But if you people have anything you want us to talk about, or you want to see us discuss and research, you can send it to us and we will include it in one of the upcoming topics. So that's all I wanted to say. Just phone it in. You can do it during the meeting, but that's a little problematic. You might send it by email to us between meetings.
Well,
Okay.
assuming there were some people hooked on the show last week, would you like to apologize for the last 10 non-existent minutes?
Yeah, apparently my home was invaded by aliens and they tripped over my computer wire.
And
No,
it became a
seriously,
cartoon.
my computer froze up because I gave it ambiguous instructions of what to share. And when that happens, the only thing I can do is shut down the computer and start it up again. And when I did that, it asked me to put in the meeting ID number, which I have long since forgotten. And so trying to get the meeting started again, I shut everybody else off. So sorry about that, folks.
You suppose those things happen to people holding big, important government commission meetings with dozens of pictures, or
Oh, yes.
We can only hope.
No, they do.
well, I'm ready for another hour. No, there it is. Why am I hungry? That's a hungry.
Okay, this is a picture of a full moon, not full moon from yesterday, but it's a
Oh.
nice picture. It shows the ray structure here going.
It's totally blown out.
Oh, oops. Okay, here we go, folks.
Uh-oh, be careful.
I know.
You do this, we go away. But I thought it was okay.
It wasn't
Yep.
showing the ray structure though. It was entirely white in that area.
I got to tell you, if
There
There
the,
we go.
There we go.
Okay. So this is a better picture of it. Shows nice structure of the moon. You can see the mare here, and pick out the man in the moon, which for me is, if you squint, because this is too high a magnification and really see the man in the moon, but this is his mouth, this is his nose, and these are his eyes up here. And he's kind of smiling down on whoever's over there.
got it.
There are other patterns up there too, but I don't pick those out by eye. Anyone want to suggest one?
Yeah, LeBron James at the top.
Yeah, this
It's
soccer player.
the soccer player. Yeah, but you
Oh,
know,
he's upside down though, isn't he?
he's sideways. If you look at that's his body, and then to the left is his head, and then the legs, and then out
Oh.
up at the top is the basketball,
This is the soccer ball.
soccer
Yeah.
ball.
Yeah.
Yeah,
And his head is no, come up. His head is Sea of Serenity right
right
there.
there.
You can
Okay.
see his nose pointing up.
Oh,
it's-
okay.
And then the Sea of Tranquility is next to the right, and that's his upper torso. And his
Okay.
arm reaching down there is the Sea of Nectar. And then if you come up there, that's the Sea of Fertility. That's like his lower torso, and the rest of him is hanging off the other side of the moon.
Okay.
Huh.
Yeah, when I was a kid, everybody would say, "Oh, there's the man in the moon," and I never knew what they were talking about.
Now there is also a lady in the moon, and I think, what did you call it? Tranquility and Serenity, or the hair?
Yeah,
And
that's
then
the hair.
and then a little bit down is the eye. Just down a little bit is the eye of the lady
There's the
right
eye.
there, and then nose and mouth below that, right there.
And then come down more, and there's chin.
Yeah.
More to the right, to the right.
The-
Well, that's neck, and then
Yeah,
come up a
that's the
little, and
neck.
there's chin.
Chin right there.
Oh, it's a
Yeah.
profile.
And then her face
That's a
is to-
profile.
yeah, and then
Okay.
her face is to right in there.
Boy, that's a reach.
It really shows up well sometimes under some phases.
Yeah. Yeah.
The only thing I could spot when I was a kid was it looks like a peeled orange.
Yeah.
When I look at the moon, guys, when I look just naked eye, I don't see the man in the moon that you see. I see a really beautiful face on there that would be kind of reminiscent of sort of like Mona Lisa. And
Huh.
it's so I see a real clear moon. As a matter of fact, when I first joined the club, I asked Chuck a really kind of crazy question. I said, "Do you think that maybe a past civilization could have exploded some craters on the moon to paint a face on it?" And he went, "Oh my God." So,
You just started a cult.
yeah,
Yeah, you
yeah,
did.
yeah. When Chuck heard that, he said, "Yeah, there are some other crazy people too." You know?
What do you suppose if the other side that we never see was tidally locked toward us? It would be a
Yes.
different thing. We'd see
Oh
nothing,
yeah, oh
see
yeah.
nothing but holes, pimples, a bad case of measles.
It's just complete. It's almost all just craters, and there's
Good thing we can't see it.
Almost all highland, just a couple of small mares.
Yeah.
Amazing.
Okay,
Oh,
well,
here's-
this is the next 1, 2, 3, 4, 5, 6, 7 slides are what we would have seen in the last 10 minutes of it yesterday or last week's show.
Chuck's
This
favorite
is the-
map.
What's
let
that?
Chuck share something.
Yeah.
Oh,
Like,
Well, go ahead and talk about Psyche. I can show the occultation thing again. I think it managed to get shown last time.
no, I didn't see it.
Okay.
No, I
was
didn't either.
struggling with my machine. So anyway, this is the night sky. This is an anti-Chuck diagram. But it's
This one's
simple.
better than most.
Yeah, I figured it was acceptable. And I didn't want to redraw this curve on my planetarium software. So this is Aldebaran, easy to spot in Taurus. This is a half a degree legend here. So the Psyche is about 1, 2, close to 3 up here. It's at 3. Today is January. Well, we're at the tip of the point now. Last week we would have been down here.
Oh, shoot.
So it's up here now, the asteroid Psyche. And what's its name? NASA has whoops, that's 10 slides away. Okay, we're going to have a shot here to go back.
Okay.
Okay.
It's rather complicated. Yeah.
And that's going to give us a problem too.
So that curve means that the psychotic asteroid is going around the edge of the ring of the asteroid belt, right?
It means
Or we're just passing it on an inside orbit is more likely.
right. Okay, now these
Well,
might look white, but maybe you can see the words.
Yeah.
There is a way that you can look at take pictures, take a long video of an asteroid, and you can notice the detailed changes in brightness of it. And from that, you can infer a mapping of bright and dark areas. And that's been done here for two views of different sides of different places on the asteroid. This is Panthea, and this is Panthea. So this is plus 20. I don't know which one's
degrees.
They're degrees, but I don't know which one's longitude and which one's latitude. So
Different
anyway,
rotation.
What's that?
Different rotations.
Yeah, different rotations. Thank you. Lifesaver. But you can tell these will probably resolve in once we get it close to it and orbit it. We'll probably see these things as actual detailed craters. But this is all we know about it yet. And this is the axis of rotation.
But it's football shaped.
Kind of.
An ellipsoid.
And why are we orbiting it?
We're not yet, but we're about to. It's just part of our exploration of different asteroids. This is a unique asteroid. Yeah, it's basically a chunk of metal. And the likely scenario for that is, as you all know, that this was once a planet, a growing planet, and it became differentiated. So it grew long enough that it was crushing its core, and things became liquid, and all the heavy elements went down to the core. And then it got slammed with something, another planet, and it blew away the crust and the mantle, and all you have left is the core. So here's your opportunity to observe a planetary core or a protoplanetary core, depending on how far along it got. So that's the uniqueness of this one.
Well, it looks a little like the Death Star in Star Wars.
Well, this is an artist rendition. This is not a picture of the thing.
Still looks like the Death Star a little bit.
It does a little.
That big round, one big collision and another almost as big next to it. It seems like.
Looks to me like Popeye's face with one squinky eye over here.
Okay, and we're going to orbit it, but not pick anything up, not land.
There are no
correct.
plans that I know of to pick anything up, at least this trip. And
Need a
I might
blowtorch,
hard to
maybe.
pick up.
All right.
So this is the satellite. It's quite large. These are, it's traveling. These are thrusters, and it uses, it's a special word for it, but it's a special kind of ionic jet, ion drive from Star Trek. And it's going there with this ion drive too. It's not using reactive rockets, where you have two fuels that you light. So it's using fairly advanced and for ion drives, fairly energetic. This shows the same thing, but it shows people for comparison. And so you can see that this is a fairly substantial package. And here they're working on the attitude jets down here. So they'll send someone up there to space once it's launched and unwrap these sections.
The mission is called the Psyche, named after the asteroid, but the probe itself is the TESS.
No, this is Psyche.
Yeah, TESS is different satellites.
TESS is different. I'm sorry, I thought that was on this one.
TESS is going to show us a picture of 3I Atlas in a few frames.
Oh, that's right. That's a visitor.
Yeah.
Jerry?
Yeah.
The internet says that the NASA Psyche spacecraft utilizes a highly efficient solar electric propulsion, deploying 4 Hall effect thrusters.
Yeah, that's it. It's a Hall effect thruster.
Okay.
And huge solar panels.
Yeah. And these are huge. Look at them. It's going to pick up a lot of sunlight. Of course, it's going far from the sun. It's past Mars. And so the sun's only half as bright out there as it is here. But they're basically using the electricity to give them thrust.
Well, can I ask a question about wordsmiths? The wordsmiths in the crowd, psyche, is that just mental or is it psycho, like off?
Psyche is a Greek goddess.
Oh, it is. Oh, well, she must have been crazy because we got a whole bunch of words. We got a whole bunch
I
of,
think you're mixing languages and cultures on a stew pot there.
well,
This,
PSYCH is part of psychiatrists and
yeah.
psychiatry and psychotic and psychedelic.
Anyway, this is in what's called a high bay clean room. So the grills they're standing on are vacuum, are air suctions to take all the dust out. So this is a very clean room. You see everybody's, they're not in full bunny suits, but they're wrapped up. And if you have a beard like I do, you have to wear special hoods. And because you don't want a piece of dust to land in the electronics anywhere.
Might be washed out.
Are these clean rooms, Jerry? I mean, are they just every day they go in there and just take everything out and clean it? And
No, they make sure everything's clean before it goes in there.
okay.
And there are pads at the doors of layers of flypaper that you have to walk across to get in. And your shoes, you're wearing little booties, and the booties, the stickiness sucks dirt, accumulated dirt off the bottom of the booties, and suiting up and taking the stuff off and going in and out is really a hassle. So
Even little dust particles and all that, huh?
Yeah. There's
Wow.
air filters all over the
yeah,
place.
these are
Wow.
rated at I think a 10,000 clean room, if I remember the stats. It's quite a good one. There's less than, I don't know the units on that anymore.
Yeah. That's
What's
that's
that?
amazing.
Yeah.
That big panel is all solar panel.
Yep.
That's
And there's an
one
equal
of
one on the
two.
other side too.
Yeah.
Oh
This is
wow.
washed out, right?
A little bit.
Okay.
It's okay though.
Okay. So this is our sun. This is the Earth. During the time of flight, the Earth will go. Well, no, it's taking multiple years to go. But this blue is the Earth's orbit. This is the launch from here. It's going this way. This is a checkout period, 100 days in that flight. This is its path going around and coming close to Mars. This is Mars' orbit here. And so it's getting a gravity boost from Mars, and its path will go down here and up here, and it will approach Psyche in August 2029. And it's going to orbit it in 5 different orbits at different planes of the orbit's tilt. And between the different, this is orientation A, B1, D, C, B2, a very logical order. So
I
And the
have
reason-
always had the question of when you get a gravity assist, I can see it speeding up, but why doesn't it slow down on the other side?
well,
I wondered,
we had a talk about that
Okay.
because
one
I
time.
wondered it too. Why doesn't it lose when it picks up? As it's coming in, it goes fast. As it goes
Probably
away,
the
it
angle,
slows
probably the
back.
angle.
Yeah,
Yeah.
it's the angles you come in at and whether
Yeah.
and how, yeah,
And how you leave.
approach from behind and catch up, or whether you approach from the front and get run over.
Yeah.
Yeah.
But
So if
And
it's
you do slow down the planet that you suck energy from.
Yeah, you don't in proportion to the mass of the two objects, the planet never notices.
Yeah.
yeah. But I could see, I understand it now. If it comes in at a steep angle, as it leaves, it's going to be a steeper angle than that. I mean, it's going to be away.
Plus, because it's moving faster, it spends less time being pulled back.
Okay, there you go. Okay.
But is it to save money? Is that the reason we're doing all this? This ion propulsion is cheap and
Yeah,
takes its
no,
time.
it saves fuel.
Yeah, okay.
Saves fuel, saves time. So we're all still alive when it gets there. Okay.
Hmm.
So we're looking forward to that.
So Psyche is to get better astrometry on the orbit, there were occultation
Oh, that's
campaigns
right.
to catch Psyche when it passed in front of stars, and they've lost their funding for that, so it's no longer big campaigns. But coming up in mid-March, on March 15th for us, but technically March 16th, Psyche is going to occult a star, and a bunch of us have signed up to do that. Is it okay if I share?
Yeah, please.
Well,
Okay.
careful, that's what killed us last week, wasn't
No,
it?
on my machine it did.
Well, we're all connected to your machine, Mr. Perez.
So here's the path going across the U.S. and it goes out into the Pacific, where it's still daytime or just twilight over there, and then off maybe over part of Cuba. But here are the observers that have signed up so far. I'm the one on the far left. There's a couple of guys down in LA, and then some people in Arizona. And at the time I sucked this data down, there were just these five of us, but there may be some more signing up. I don't know.
Now you're this one over here, the far left telescope?
Yes, the darker one, yeah.
Yeah.
And the green is the exact center line of the path, but the lines going out to the blue are the extent of the shadow path predicted. And then the red is the error bars. So they already have a really good orbit on this.
Yeah.
So the error bars are small. But with five chords going across it like this, you get a little more data on the shape. So you can tell if you happen to encounter some of those craters and they're deep, you can see that some of the chords go a little longer than the others and things like that.
Now,
So
it looks like you've got your Celestron out over there.
no, those are meads. They've got that
Oh,
huge.
means, okay.
They've got that huge declination axis on them.
Do you know how long it's going to blink out the star?
Maximum is up here. Max duration is 11.6 seconds, so it's a nice long one. And the star is not going to blink out totally because actually the asteroid is brighter than the star. And so the entire brightness of the combined pair will drop by 4/10 of a magnitude.
Whoa.
So you get to see the asteroid?
Yeah, the asteroid's brighter than the star. So what you'll be seeing when it passes in front of the star is just the asteroid, but for a while before and after, you'll be seeing the light from both of them, so it's slightly brighter.
They merge and get to be a brighter
Yeah,
configuration.
from our point of view, they merge just with the resolution of your telescope.
Well, that's normally not how an occultation takes place, is it? Star
Yeah.
goes away.
Well, because most of the time the asteroid's dimmer than the star, but in this case, the asteroid's brighter.
And what's the star's name?
UCAC 552012459.
Of course, we all
Oh, that one.
sure.
Magnitude almost 13, 12 and a half.
Oh, that
Wow.
one. Okay, got it.
Up in Taurus.
Right there under target star.
Yeah. And it's in Taurus, so like Jerry's orbit showed, it's still up there in the bull.
Have you ever, Chuck, had an occultation happen during a star party?
Yes.
And in fact, one's going to happen during the February star party.
Well, they only have a few seconds to look at it, don't they? Before it's gone.
The one at the star party will be 4/10 of a second. Yeah.
He did the last Westmont. He did one for the people.
Yeah.
In January, and he had a huge crowd around his table. And
Yeah. That one was I think 10 seconds or 20 seconds.
Oh, a long one.
Yeah, it was a long one. And as my recording software was counting down to the event time, there were a bunch of kids in the crowd around me that were going 10, 9, 8.
right. Yeah, it was amazing. There was a big old crowd around his table. And Chuck was saying, I bet you they were underwhelmed.
Yeah.
I don't think so. I don't think so, because there was a lot of people interested in, as Chuck sets this whole thing up, Ronnie, it's pretty amazing. He's showing everybody all his gear, and I mean, even us, when we were there, we were turning around and peeking about what he was talking about, because it's pretty interesting.
Yeah, but
Yeah,
4/10 of a second. I'm sorry, that's just like the twinkling stars we see anyway. They
Yeah, but the star goes away. It doesn't just change brightness slightly.
just winks at you.
Yeah.
Yeah.
Well,
Yep.
plus, immediately after I can suck it down and do an analysis on it and show a graph of the brightness, although that's a little less visually compelling.
Well,
Yeah.
I'm thinking that a planetoid type of rock, like a Ceres, would take many, many minutes to occult stars all the time, wouldn't it?
It depends depends on the path across the chord that it's doing. If it's out near the extremes, then you might get a shorter one. Not much, but
How about the Mercury transit or Venus transit? The Venus transit on the sun, that was like that's very rare.
yeah.
And
And that was
we
hours.
and we actually got to see that out at Big Box.
Yeah.
I didn't understand what you said. You mean
Oh,
Venus occult stars?
No, Venus transiting the sun. That's like Venus occulting the sun.
Oh, I see. Got it.
the
Okay.
planet Venus, the path it goes right in front of the sun, and we got to see the planet as a silhouette going
Yeah.
across the sun's disk.
But it probably also occult stars behind it, wouldn't you think?
Well,
The
maybe,
planet, the
but
planets are going different than the
Yeah, it
stars. They're
does.
locked.
It
Yeah.
does, but Venus is so bright it pretty much overwhelms any measurement. It's much tougher to measure because Venus is so bright.
I mean, they've written books about this stuff. That it's really fascinating, the information they got from those very rare events.
And with
Got it.
these stellar occultations, you can actually get the shape and the position is more accurate than any other astrometry method that they have. And you can get the shape more accurately than Hubble or Webb can measure it. And I can be stupid. I just have to find the star and watch it wink out. So,
It seems to me like there'd be occultations happening. There's enough bodies out there
yeah.
all the time.
Yeah.
I don't
For
know.
this month, I had 44 candidates
Wow.
that I could see with a 5-inch scope. And the bigger your scope, the more you can see.
And
So
they
yeah, there are
stand in
people that have robotic observatories that are doing 10 and 20 of these a night.
Wow.
Oh God.
and just for posterity, they're saving it all. Like we're going to care and look into
No,
what.
no, it's used to get really fine astrometry on the positions of the asteroids
And the shape of the asteroid
and the shape.
and any moons.
Yeah, and any moons.
And there's
There's
millions
one
of.
tonight that I'm doing that's asteroid Sylvia, and it has 2 moons. And so there's a bunch of people signed up for that one too.
What has 2 moons? An asteroid?
Yeah, Sylvia.
I heard of
Romulus
one.
and Remus. It's named after Rhea Sylvia, who was the mother of Romulus and Remus,
Huh.
but might not have been a very good mother because they ended up being raised by a wolf.
See, I've always wondered if there's a moon in our solar system, a moon that would orbit a planet that has its own little moonlet. Does Pluto have one?
Pluto has 5 moons.
I know, but do any of the moons in the solar system have their own little orbiting moons
You've
like
asked that
Astro?
before. That's dynamically tough to do.
It is,
Yeah.
and yet it happens in the belt.
Well, that's like a planet and its moon.
Yeah.
Oh, okay, got it.
I mean, you could probably do that with a moon and a planet if you had a moon way out. So some of these moons of Jupiter that are way out, they could potentially have a moon also, because the gravitational influence of Jupiter would be much less at a great distance. So it could
Oh,
potentially happen, but we haven't found any.
I don't know. Mars has 2 little potato rocks that aren't even really qualified for size anyway as
Well,
moons.
our moon had a moon for a while the astronauts were landing.
Yeah.
Really? What was it?
It was called the Apollo capsule.
Right.
Oh, I see. Well, that leads me to wonder why can't a rock do the same thing, get locked in, become a moon of a moon or moonlet? Maybe moonlet would be the word.
Yeah, but see, our gravity, our effect on it would tend to knock it out pretty quickly.
Really? And yet that doesn't happen on the other scale. Sun to planet, planet to moon.
Well, there is if you calculate librations for the moon, if you want to figure out how it's tilted and look for some of those craters on the edge of the moon, you have to take into account the gravity of the sun and the gravity of Venus.
Lagrange points, things like
Wow.
that.
Yeah.
How many Lagrange points are there? 6?
5.
5? That doesn't make sense. That's not an even number at all.
I'm guilty of being one that asked that very question that you're asking, Ronnie. So, you know, I'm the one that I think was original one that asked that of Chuck. Can a moon have a moon? And it always fascinates me.
That's why I love having you on the screen with me, Tim. You're the other
I know.
dummy.
Okay, Jerry,
Okay.
take over.
Onward, Christian soldiers. Here we go. Or did I speak too soon?
Okay, Tess and 3i.
Oh, wow.
This is a picture of 3i Atlas taken by Tess.
There's my Tess. Okay, it's moving.
Yeah. Zooming.
You can even see a little bit of a tail here.
Yeah.
Yeah, yeah. I thought earlier when you mentioned this, I thought you were talking about Tessa.
Yeah.
That's a Flanagan.
Yeah. Boy, that's some image. I mean, video.
Yeah.
Can you go back to it again, Mr.
Look
Well,
at
this is
You know
a single frame from that video now.
Okay, but it was looking like that UFO they spotted something going in there. The certs or whatever what are those things you chew on? They called it a white. This was
Tic
the
Tac.
UFO problem. It's
Tic
going
Tac.
across the ocean.
You're
You know
thinking
the
of
one
Tic Tac.
Tic Tac, yes. If that's
I don't know
not
what
the
you guys
ocean.
are talking about.
Oh, he's talking about the UAP videos from the infrared sensors on the planes.
Oh,
Looking down and following this thing that's shaped just like a Tic Tac. But the moving is gone. Here we go. What is that?
okay.
Tess?
Now this is a picture of Tess,
Got it.
and this is a processed picture of 3i Atlas taken by Tess. That was a single frame video. Here they're processed to get a really good sharp image of the comet. And it is just a comet.
Yeah.
Does it mean it had to come from another stellar system?
Yes,
It
this
didn't
is
come from
3i.
ours.
What? I missed what you said.
Go ahead, Chuck.
This is 3i. That's what the I means, interstellar. This is the
Yeah.
one we were talking about a couple of months ago.
I know that, but is it possible? The odds are that it came from a stellar system. It doesn't just come from interstellar space from the middle.
Well, once it left that other solar system, it was in interstellar space.
Yeah,
But they can't calculate by looking where it came from, its track.
they can. They
Which
can,
star?
after 3, in principle, at 3 observations of a moving object, you can tell its trajectory. You can tell the whole path that it's on right now. But that doesn't mean it wasn't perturbed by something before it got into our field of vision. So it
And also, they figure this thing's been floating around for several billion years.
yeah.
If you try to trace back its origin point, you have to account for that origin point's orbit around the center of the galaxy and all kinds of stuff. So it's tough.
Yeah, it's an open question.
Yeah.
Stuff
But for
gets thrown.
Oumuamua, that one they managed to trace back, and it was in the vicinity of a red dwarf star, one of the Gliese stars.
Really? And something tosses it out.
Yeah.
Okay,
Interesting. Fascinating.
moving along.
What is
This is what is called the Boomerang Nebula.
Oh,
It is a bipolar planetary nebula. That is, it's got 2 lobes, which you can easily see here. That's 5,000 light years away in Centaurus, which means you don't get to see it from here with your amateur telescope. So it is also renowned as the coldest object in the universe. Its estimated temperature is approximately 1 Kelvin. the background of empty space just pointed at a random black spot in the sky is about 3 Kelvin.
It's
So
Kelvin, the 0 point.
Kelvin is like
0 is at 0
Celsius.
Kelvin.
In other words, it's 1 degree above absolute zero.
Yes, yes.
1 Kelvin. Yeah.
Right. So the effect is like if you take one of those cans of dust remover, you know, spray dust remover that's compressed air, and you hold the button down on it, or you get one of these annoying sound machines, a horn that's on a can of compressed air.
Mhm.
Hold the button down, and pretty soon it doesn't work because it freezes up. Because expanding gas cools the gas that's coming out. And this is a high pressure gas that's coming out, and that's why it's so cold. Because it's expanding very rapidly.
Huh.
Well, you wouldn't
As a
think
matter of
it.
fact, the gas is escaping from the central star at roughly 500,000 kilometers per hour. It's acting like a refrigerator.
But one wouldn't think that it's colder than the surrounding empty space around it. But we don't consider that a place, do we? Or
But that's at 3 Kelvin.
Yeah.
it's colder than the background radiation.
Yes.
Yep.
That's like what, 3 Kelvin, 3
Kelvin.
degrees?
Yeah. Just like you have the inside of your refrigerator at your house, it's colder than the surrounding house.
Well, I understand
Because
that.
there's a refrigerator operating in there. Here, the refrigerator is the rapidly expanding gas.
But what they're saying is life probably doesn't exist there.
Yeah.
Maybe a few, Malamutes or Huskies or something, but
Yeah.
If it is,
Polar
it's
bears.
moving. If it is, it's moving pretty slow, Ronnie.
But it's
so
pretty bright for
this is
that
taken with
cold.
what?
It's bright for being that cold.
Oh yeah, yep. So this
I
is
always
taken by
heard
the
brightness
Hubble's
meant.
wide field camera.
Ooh.
Oh,
This is taken with the advanced camera for surveys on the Hubble. And you can see the 2 lobes. Let's see, this is imaged using polarizing filters analogous to polarized sunglasses and color coded by the angle associated with the polarized light.
I must have missed that in the talking points. This
It
is
was in the caption for the picture.
it's really pretty.
Yeah.
Rainbow.
This is beyond your eyesight. This is taken by the Atacama Large Millimeter ALMA radio telescope.
Big molar, huh?
Yeah.
What's that? Big molar, yeah.
With a cavity.
All right, there goes the tooth carver.
yeah.
So nebulous lateral, just a second.
And some of this, Ronnie, isn't just gas. Some of it's dust because it's so cold. It's formed molecules and stuff. And so it can be scattering light from that central star, not necessarily fluorescing. So it's the fluorescence that would tell you the temperature
But still, to my thinking, light is energy. That's all it is. It's pure energy. To think it'd give it a few numbers on the old Kelvin scale, wouldn't you?
but it's just scattering off of this stuff. It's not necessarily heating it up.
Light is an excitation of the electromagnetic field that permeates all space. And it contains energy, it delivers energy.
Well, we don't even see light technically from a black hole. Is that the
That's
cold?
because there is no light from a black hole.
Yeah.
I know. So how cold or how hot or how warm or is there any temperature involved with a black hole?
Actually, that's a good question.
We don't know.
Obviously, I don't have an answer, but what's his name? The guy in the wheelchair. What?
Hawking.
Stephen Hawking, yeah. He
Radiation.
calculated the temperature of the surface of a black hole.
That would be his radiation, right? That's slowly seeping out.
Mm.
So this one says it's possible that this is the cause of the which is engulfed in a small. Oh yeah, The nebula is thought to have formed from the envelope of a star in the later stages of its life. That is, becoming a globular,
Planetary.
a nebula, yeah, which engulfs a smaller binary companion. It's possible that this is the cause of the ultra-cold outflows, which are illuminated by the light of the central dying star.
Huh,
So it's a binary star.
Huh.
okay.
And this is another picture taken also by Alma, emphasizing a different wavelength.
But we don't have jets going in opposite directions that make that,
Yeah, there's jets.
okay. Oh, it is jets.
Yeah.
Okay.
Okay.
It denotes spinning to me.
Yeah, did you see that, Jerry? It almost looked like there was some kind of rotation.
Well, it's a binary star.
What do you
Oh,
mean
okay.
rotation?
Okay.
It's a still picture for me.
Yeah.
In the dust lanes, leaving the central area, it looks like they go in an arc.
But there's two stars in there. Is that what we're
Oh,
looking at?
Yeah.
you're looking at these rays here.
Yes.
Yeah. No, I don't know. It might
That
be, as Chuck says, it might be rotation of the emitter.
and
Yeah.
and it could be also magnetic fields, are bending some of that stuff. Some of it
Yeah.
may be charged particles.
Huh. Okay. Okay.
And there's a diffraction thing here that might be a telescope artifact, but it also might be some kind of a protoplanetary disk.
Wow. Interesting.
But the
Okay.
only reason we saw that much is left the lens open. You'd never be able to see this instantly like that.
Right. And this is ALMA, so this is microwaves.
Oh, it
Yeah.
is.
Yeah,
I
this
didn't
is
think you
cold
could see
stuff
any-
here.
I didn't think you could see anything like this with a naked eye. I've never seen anything. So little dots. Can you see a dot there as a naked eye vision? Where
I
that
don't
is?
know if they
Yep.
gave the visual magnitude for
Yeah.
this.
Oh, got it right. Anything below what, 6?
Right, you wouldn't see with your eyes.
Well, you would see with your eyes below 6.
I don't
Below
see a
6, you're right,
reference to
yeah.
the visual magnitude.
I thought that I read it was 13, but that's maybe I'm
No,
thinking
you
of
might be right.
Well, most stars are doubles, aren't they? Most are binary,
Yeah.
more than half. And some of them are trinary. And what's the maximum before they become a star cluster?
I think we found 6.
6, okay. My God.
Yeah, there's no mention of the visual magnitude in the,
Okay.
talking points.
I didn't see that.
Okay.
Okay. So now we're moving on to an open cluster in Camelopardalis. Now I know this is the constellation of the giraffe, but I keep thinking of it as the camel.
That's right. Somebody got their animals wrong on that one.
It's the spotted camel. Pardalis is, like leopard.
Yeah. Oh,
Leopard
okay.
is spotted lion, leopard, and this is camelopard, so it's spotted camel.
Okay.
But there's a giraffe picture with this constellation.
Oh, well, that's what they used to call giraffes, spotted camels.
Oh.
So
Okay.
this
And a
is
long neck.
this is a hard to find cluster in any in the literature. It's Colander 464. Go ahead and look that up.
Yeah.
So it's near a star, Alpha Camelopardalis, which apparently is not a named star, but it is the star that is here in the crosshairs or the pointer. And it's a small hop. Let's see if I have that. Okay, I don't.
Do you happen to know exactly where like 150, I think it's 1502 is, that's at the base of the Kimball's Cascade.
Well, it looks like it's see the little triangle there on the left. You can see a little cascade heading up to a little cluster.
Yes, that would be it, huh?
Yeah.
Okay.
You mean this here?
Yeah. And then that would be 1502 there, I think.
Oh, okay. The this little cluster here contains 471. Oh, the Colander catalog contains 471 open clusters compiled by Swedish astronomer Per Colander, published in 1931 as an appendix to Colander's paper on structural properties of open galactic clusters and their spatial distributions. This catalog, not the cluster, this catalog contains 452 open clusters, 11 globular clusters, 6 asterisms, 1 stellar moving group, and 1 stellar association. So these are apparently very faint and obscure clusters that are skipped over by most other catalogs that he decided he had to
Look them up.
look them up.
Listen,
Name them.
Except for the coat hanger cluster. That's a colander cluster.
Yes,
Really?
that is true. Now this is what I just read you. This is his Colander's calendar. But this is Alpha, which is the one that had the
bullseye.
Yeah, the bullseye on. This is IC 342, and this is Colander 464 up here. So it's along the base of this triangle and up a little. And this is the only picture that I could find on the internet that claimed to be Colander's cluster. Now, I don't know where it is in there.
I bet it's, you see the middle star? I bet it's up and left of that, because if you look back at
Up
that
here?
yeah, right in there.
Well, I think it's meant to be all the bright stars you see in here.
Yeah, that's my reading of it. Because
Oh.
they talk
Oh,
about
okay.
it's a sparse cluster and it has orange and blue stars in it.
Oh, okay. Okay.
So my guess is going with Chuck.
Yeah, I think Chuck's right. Yep.
And they said it looked like a profile of a toy poodle.
Yeah, I don't get that at all.
I don't
I
get
don't
that
see
either.
that at all. By the way, the boomerang cluster, I looked it up. It was 11th. They listed as 11th to 12th magnitude, visual magnitude.
So you
Okay.
can see that in a 6-inch or 8-inch telescope in principle in the dark.
Yeah, but
So
not
this one,
particularly.
I've looked so long at this, trying to figure out what was what, that I've actually picked out my own asterisms. So this is the right eye. This is the left eye. This is a mouth. This is a nose. And this is some kind of crown he's wearing. So you can tell I've looked at this too long at late night.
And there's a nice little arrow pointing upward down below by that little triangle. Yeah.
Oh yeah, that's neat.
Yeah, and it's pointing to this little 3-sided cube.
You know, Jerry, I used to, just an aside, I was a dental technician, so that I spent hours at a bench carving anatomy in teeth. And my boss lived up in the Riviera, and one night I went to dinner at his house, and all the city lights, we were overlooking all the city lights. And I said, "Come here, quick. There's a lower left first molar, the anatomy right there." And like the lights to me, that it reminded me what you said. If you look at it long enough, you'll see something.
So they reached over and took your glass of wine away, right?
Exactly. It was he was cracking up at me because you've been just working too long, man.
Now this is IC 342. Whoops.
There it is.
Which is right here near Alpha.
Yeah.
So Colander's up here, but this is a really nice but small and faint galaxy. And this was imaged. It's
It looks like it might be Webb because of the diffraction.
Oh yeah. Yeah.
oh no, there's another. See, the Webb has 6 like this does, but it also has a faint one that goes across.
Secondary ones,
The
yeah.
secondary, and this one doesn't have that. So this is
Obviously a distant galaxy.
Oh, it says Euclid.
yeah.
Euclid galaxy?
No, the Euclid
Oh,
telescope.
Yeah.
Oh, the telescope.
Euclid satellite with a telescope on it.
Oh, I can't see that. Where's that at?
It's in the caption. Euclid used its near-infrared instrument to peer through the dust and measure the light from the many cool and low-mass stars that dominate the galaxy. But it's a face-on spiral. It's very, very nicely delineated. It looks like it's got at least there's a star there, and then it's got some real bright structure in the core.
Yeah. That's blown out here, but it's still decent enough.
Oh, okay.
Is this the colander we're looking at?
No.
What was
Colanders
colander?
are open clusters. This is a galaxy.
Oh, okay,
Yeah.
got it.
This is an IC, so that means index catalog.
That's not M106. We haven't got
No.
to that yet, have we? That's the last item on the agenda. M106,
Yeah.
distant galaxy. Moon is starting to wane. Actually, it's as bright as it can be right now, isn't it?
Yeah.
See this okay?
No, not at all.
You're not sharing.
Dang.
I have a feeling we're about to get unplugged again, Tim. Brace
Uh-oh.
yourself. The end of
Fasten
the
your
program.
seatbelts. There. That's still blown out.
Oh, that's the same, yeah. Dang, I'm gonna get this right.
Look good here.
I
Looks
just wish
even
we
better
had
when
the-
it's not blown out, though.
I wish we had the ability to play music, different science songs and classic Carl Sagan speeches and things like that. It would be nice.
Okay, how's that?
That's great.
Okay. So
Okay.
there's a star there. There's a bright glob there, little dark lane. It's very detailed. And
Wow.
thousands of galaxies in the background.
Yeah.
Okay.
What's the
Jerry,
name
can
of
you
this?
zoom that just a little bit so we can see that central region?
What's this called again?
Look at that. Look at that.
This is IC342.
Yeah.
Okay.
That's
is that?
amazing.
What does that mean? That's not an M or an NGC.
IC is index catalog.
So that's a third cataloging behind M's.
There's hundreds of catalogs.
Is there really? I see.
The detail on that is amazing.
Yeah, there's that nice, you can see the dust arms delineating the spiral arms way down to the core.
Yeah.
Yeah.
And I think you could even resolve stars in this.
Yeah.
You know, Dick Beam took a picture of it with one of those red cats. And
Yeah.
this reminds me of the time where he just kept blowing it up and blowing it up. And you could still see details. It's reminiscent of that. But I'm sure this is just amazing. When Jerry blew this up, I did not think it was going to refocus, but it sure did.
Yeah.
And yet this is not part of the local group.
No, not that I know of.
But, so how far away is it? And is it as big as our Milky Way? 100,000 across?
Didn't mention.
Well, it looks the same. Well, all right, now we're going to visit M10, what is it, 106?
Wait a minute.
That was really fascinating, Jerry. I didn't realize that we could blow it up that big.
This is M106 right there. This is the Big Dipper up here.
Mm-hmm.
And down here, this is the realm of galaxies. You know, the M51 is there, M101, M94, Corcoroli, a star. And then M106.
This is the opposite star hop from finding 81 and 82.
Yeah.
Well, what's Messier's last number? Do you know?
110.
110.
So he was close to the end of cataloging with this one, wasn't he?
Now, this is an amateur picture of M106.
God.
That's great.
This is what you might expect to see.
Incredible, man.
Yeah. And then this is a picture of M106 taken by the Hubble Space Telescope with a little help from an amateur astronomer. This was processed by
Rob Gendler.
Rob Gendler and Jay Gabaney.
Oh man, that Gendler guy is like he's a man. Amazing.
Yes,
I knew
now
it
it's
was Gendler or Gendler. I never knew that.
Yeah.
Gendler, I say.
Okay.
I think it's a German name, and you'd pronounce the G, G.
Okay. Boy,
This
here
is
we go
a
again.
very
Look
interesting
at the
star
detail.
cluster here. All these resolved star clusters. There's a nice jet of gas and dust. Absolutely excellent processing.
That's 106 right there. Huh?
Yeah,
And that's not part of the local group either.
yeah, it is.
Oh, it is
Well,
part of the
it's part of the
local.
Virgo cluster, probably.
Right.
Or
Oh,
the Coma cluster. It's in Coma Berenices.
And
well,
see,
some of
this
those
arm
local,
down here is completely resolved into stars.
Yeah.
Oh, that arrow. What is the arrow? The arrow there referring to? Oh, that's just a cursor. Okay.
but
Yeah.
is it a radial? It's not a what do they call those big balls of?
Globular clusters. This looks like the Rosette Nebula with a cluster in the middle
Yeah.
of it.
Uh-huh.
Huh. But old Messier caught this in his telescope and toward the end of his life, or his,
Well, there's complications with that, not necessarily, because a bunch of them, at first, that catalog only had 103 elements in it. And then later, people went back and looked at his and his assistant's observing logs, and they added more to bring it to 110.
but your Virgo that you're talking about, Virgo cluster, are those the orbiting satellites or satellite galaxies of the Milky Way, or
No, no, the
both up
Virgo
and
cluster,
Andromeda?
there's a Virgo supercluster and a Virgo cluster, and those are just, big collections of galaxies about 50 million light years away.
Okay,
That's just our
among them
neighborhood.
is Triangulum and Magellanic Clouds. Those are all part and parcel of that, aren't they?
Well, the Magellanic Clouds are tied to us gravitationally. M33 and M what 31.
32 or 31,
Yeah, they're
31,
those,
32, and 110.
those are
That's it.
very far away.
Yeah, that's that group.
So this is a picture of M106, and it's added X-rays from Chandra in the blue here and here, and radio waves from the VLA in purple.
Very large array.
So this is the blue is very high energy X-ray emission, and the red is very low energy radio emission.
Actually, that's infrared from Spitzer, it says.
Are they
Where do you
jets?
see that?
For the red.
Oh yeah, infrared from the and the red. Yeah, I was just looking at the purple,
Yeah.
purple and blue, and then yes, and then the red is
Infrared, so
the
dust.
yellow and blue is from Hubble, and the infrared is from Spitzer.
But are we looking at arms of the galaxy or jets coming out? You know what
They're
I'm
calling
saying?
them anomalous arms.
Yeah, I don't know what you're looking at. Are these arcing up and out of the galactic plane? Probably not. These are in the galactic plane.
They do seem to overlay the other arms, though, so it's weird.
My desk chair just wiggled slightly. I wonder if we had like a level 3 earthquake.
Really?
Didn't feel anything here.
Okay,
Nothing here either.
that could be my cat waking up.
Probably another Elon launch.
Okay, well, that does it for today.
Yeah, it does, gentlemen. We ate up a little time here. That's okay. Program number 258 behind us. 259 is next week. This is the SBAU Astro Hour. We'll see you on Friday night at the museum. In the meantime, how do we say goodbye, Chuck?
Hasta Nebula.